Okay, so looking at what you guys were doing for this, you did a really good job of coming up with the answer, and I got a ton of participation, which is really great. So I just show your responses. When you are trying to find theoretical probability, it's just a fraction that you can write where the numerator is the number of favorable or desired outcomes. And so if we're rolling a six-sided die and the theoretical probability is that you will roll an even number, well, those six sides, we have 2, 4, and 6. So there are 3 possible outcomes that are favorable. And then the total number of possible outcomes, it's 6 sides on this die, so that's why 6 is in the denominator. Now you can leave it as 3/6, that's correct, or you can simplify it to 1/2, 3/6, 1/2. Okay, so those are both correct. I'm going to even put something different that's also correct. I don't know where it went though. Maybe they changed it. But they did have it correct because they did mark it correct. Okay, so probability could be written different ways. And, you know, I showed you guys how to write it as a fraction. And when you take your Unit 8 test on Friday, it's going to be set up such that you have to enter your answers as fractions. So that's why I'm showing you it as a fraction. But there's actually, you know, many ways to write your probability. You can write it as a decimal, a fraction, a percentage, or sometimes you can say like 1 in 2. Okay, so this is just an example here of 4 different ways to write it for when you toss a coin and you get getting ahead by tossing a coin. The probability, I've showed you guys how to write it as 1/2. Okay, but if you convert it to a decimal, that's still correct. If you convert it to a percentage, that's still correct, or you can even write it this way. Just some review of last week. So the different ways of showing probability, remember probability is represented by a number anywhere from 0 to 1. If it is 0, the probability is 0, it is an impossible thing to happen. If the probability is 1, then it's absolutely certain to happen. Okay, right in the middle, an even chance, this would be probability of 1/2. And then you have any other value anywhere on this range from 0 to 1. These are all going to be proper fractions. Okay, so if something's unlikely, you're looking at a fraction that's less than 1/2, maybe 1 in 6 or 1/6. Likely would be 4 and 5 or 4/5. Okay, so you can fall anywhere on this range of values from 0 to 1 when you're trying to find the value of probability. That's a good way to check your work. You shouldn't ever get a negative answer for probability or a number, a value greater than 1. So that would be something that will let you know you made a mistake. So our Unit 8 lesson today is from 2 sections in the book on independent and dependent events. And your learning goal is I can find the probability of independent and dependent events by applying the multiplication rule. So today we're going to focus on independent events, and then tomorrow we'll focus on dependent events. Okay, and so we'll look at what the definition of an independent events is. And so that's when the occurrence of one event has absolutely no effect on the occurrence of another event. So independent, think about that word, like if somebody is independent, they don't depend on anyone, they do everything their own and they don't rely on others. So independent, if events are independent, they're totally, there's no effect on one another. And so an example of independent events might be I roll a die and I get a 3, and then I flip a coin and I get tails. Those would be 2 events that are independent. They don't affect each other. And so when you want to find the probability of 2 things happening or more than that happening, this is the notation for it. This is read as the probability of event A and the probability of event B. Okay, so this little symbol here, this upside down U looking thing, This is the intersection symbol, and it's read as and. All right, so the probability of independent events, if you're trying to find the probability of events that are independent, well, this is the formula. It's the multiplication rule. So the probability of event A happening and event B happening is equal to the probability of event A happening multiplied by the probability of event B happening. Okay, so if I'm talking about rolling a 3 on a die as event A and flipping a coin and getting heads as event B, then I would just multiply 1/6 times 1/2, and then I get 1/12 as my solution. Okay, so that's what we're going to be using today, the multiplication rule for independent events. Here's our first example. So we're going to find the probability of the independent events. It says every morning one student in a class of 24 students is randomly chosen to take attendance. What is the probability that the same student will be chosen 3 days in a row? All right, so the probability of each of these events, and there's 3 events here, they don't depend on each other, they're independent. So because these are 3 events that are independent, we would use the multiplication rule and multiply the 3 probabilities together. And so I'm going to show you what this looks like with notation. You don't really have to do the notation on the test, but I did want to kind of just show it to you so you can see it. You just need to do the calculations for the test. So we have the probability of event A, which is that one student gets chosen, and that one student gets chosen again, and that one student gets chosen again. So because these are 3 independent events, it would just be multiplying each probability together. So the probability of A times the probability of B times the probability of C. So that rule I showed you on the last slide works for just 2 events. It also extends to 3 events, 4 events, whatever number of events, as long as they're all independent. And now I just replace each of these probabilities with numerical values. So this is the part that you'll have to be able to do. So what is the probability that a certain student gets chosen out of 24 students? If it's random, equally likely that any student is chosen. Well, number of desirable outcomes is 1. Total possibilities is 24. So we have the fraction 1 over 24. And then that happens on the next day. Well, again, there's 1 possibility that we want, and there's 24 total possibilities. And on the 3rd day, still, it's the same exact probability every day. Now, what I need to do is multiply these 3 fractions together. And when you multiply fractions, if you forgot, you multiply the numerators, right? 1 times 1 times 1, and you multiply the denominators. 24 times 24 times 24, 24 to the 3rd power. You could think of it like that. You don't really have to write that intermediate step, but I just wanted to show you where our numbers are going to come from, because this denominator is going to be a really large number. 1 times 1 times 1 is 1. And then 24 times 24 times 24 equals 13,824. So that's the probability that we're going to pick the same student 3 days in a row to take attendance. That's very unlikely. 1 out of 13,824. So I'll give you another minute here to just get that copied down. Again, what's important here is that you're able to realize that these events are independent, which means you should multiply the 3 probabilities together. And you should know how to get those probabilities from the situation and then multiply them together and what you would get. So writing out this notation, this is not something you're going to be tested on, but it is nice to recognize it. Okay. All right, so we're going to go to the next slide. I'm going to leave you on student pace in case you're still writing. And so this is our second example today. Find the probability of the independent events. So from your experiment of flipping coins for heads or tails, what is the probability that you get tails 4 times in a row? So that was your experiment that we did last week. That quite a few of you still need to finish and turn in, or maybe you just didn't mark it as done and didn't get sent to me yet. We want to know the probability that we get tails 4 times in a row. So we want 4 events to happen that are independent. And so that means I need to take the probability of each individual event and then multiply those probabilities all together. And again, I'll give you the notation. So the probability of event A, which is getting tails, and event B, which is getting tails, and event C, which is getting tails, and event D, which is getting tails, is equal to the probability of A times the probability of B times the probability of C times the probability of D. And the probability of getting tails on a flip of a coin is 1/2 times 1/2 times 1/2 times 1/2. Okay, so we're going to multiply the numerators together. 1 times 1 times 1 times 1 is 1 to the 4th power. Multiply the denominators together. 2 times 2 times 2 times 2 is 2 to the 4th power, which simplifies to 1/16. So that is the probability that you would flip tails 4 times in a row is 1 out of 16, or 1/16. So when you're finding the probability of independent events, it's really straightforward. You're just multiplying it all together. Tomorrow we're going to look at dependent events, and it gets just a little bit trickier, but for independent events, it's very straightforward. All right, so once you have that copied down, the last 2 slides, the next slide you're going to go to says choose 3 videos to watch on independent events. And so let me show you what that looks like right here. Right, so this is your next slide, slide 7. And on the right-hand side, it's bringing up a website. Okay, and if you scroll through, there's many videos to choose from. So here's one video. Here's another one. There's another one. Another one. I just want you to pick 3 of these to watch. Some of them are on just independent events. Some of them that let's start talking about dependent events too, which is fine. So just pick 3 videos to watch, and then that's all you have to do.